Hi, welcome to VideoMathLessons.com, and tonight we're going to do a Math 12 pre-calculus class. The topic will be polynomials, and our lesson tonight will be upper and lower bounds. So let's take a look. So upper and lower bounds. Let's just throw in a polynomial. So I'm just going to make a random polynomial, some kind of cubic, and it looks something like this. So where it crosses the x-axis, these would be my roots, otherwise known as zeros. So, back in the day we used to always call them roots, but you should be aware that we call them zeros, or you'll hear them called x-intercepts. And when we're talking about an upper and lower bound, it's kind of like the calculator if you're using the calculate functions for graphs for the zeros or roots, they call it left bound, right bound. And all it's saying is the upper bound is this. There is a number that is past the positive root, some number over here, and that's called the upper bound. Now, the upper bound could have been over here, but all I'm saying is this. There is no root past this number that I'm using. And if I do the back part, the lower bound, that would be the lower bound. All I'm saying is that there is no root behind this lower bound, whatever number I'm using. So how do we do it? Well, what we're going to do is we're going to check with synthetic division. So we're going to check using synthetic division. And this is what's going to happen. So we have some polynomial, and I'm just going to call it f of x. And we're going to divide by x minus k. So very similar to what we used to do when we wanted to check to see if k was a root, right? We would do a synthetic division, and I would take whatever this was, or opposite sign. So if it says minus k, I put positive k in here. If this was plus, I would put the opposite. And what we would do is, right, we run through with synthetic division, and if this last number was a 0, that would be a root. Well, I'm not asking for the roots this time. What I'm doing is I'm plugging in a number, and I want to see that if it's going to be the upper bound, the maximum, where it is, or the lower bound, where it is, nothing's going to go behind it. But what we're going to use is we're going to use this last line. So we're going to do a synthetic division, and we're going to really be comparing this line right here. So what's going to happen is this. For the upper bound, so we're going to use positive k's, or it could equal 0. So if k is greater than or equal 0, if the last line is all positive, then you know it's an upper bound. If the last line is all positive, k is the upper bound. So the lower bound, well, we're going to compare it to k is less than or equal to 0. The last line is alternating signs. So like plus, minus, continuing on for however big it is, plus, minus. Then k would be the lower bound. And that's pretty much the lesson. Now, things you got to consider is that if you have if you look for all positives and you get a 0 down there, well, you're going to consider it a positive. If you're looking for positives and negatives and you get a 0, you're going to consider it whatever you need. So the zeros are kind of, neutral. So let's try a problem. It says, number 1, show that 4 is the upper bound and negative 3 is the lower bound for x cubed minus 2x squared minus 5x plus 6. Now, I already have it typed in my calculator, so once you punch it in, and let's check our graphs. And what I'm going to look for here is, like if this was one of those, all right, find the root problems, I would go to my table if I was able to use a calculator like this, right? And I would see that my roots are at -2. There's a root at 1, and there's another root at 3. And at 0, it's 6. That's the y-intercept. And let's go back to graph and let's try to graph this thing so it doesn't look too horrible. So it's coming through like this. It's coming up, coming down a little past. Something like this, very rough. So I'm just going to call it f of x. It's labeled x-axis, y-axis. And it says, show that 4 and -3 are the bounds. Well, we're going to plug in 4. We're going to do synthetic division with the 4. And I'm going to take now, I'm going to check to make sure I don't have any like gaps in my power, right? My degree is 3, so it's 3, 2, 1, so that looks good. So 1, -2, -5, and 6. And you're going to do a synthetic division on this. And if this is the upper, it should all be positive. So I got 1, 4, 2, 8, 3, 12, and 18. They're all positive. Therefore, 4 is a upper bound. Now let's try -3. So I'll plug in -3. Do it again with the original equation. 1, -2, -5, and 6. So 1, -3, -5, +15, 10, -30, -24. And see, this is positive, right? Positive, negative, alternating. Therefore, -3 was the lower bound. And that's it. That's the basic, that's the basic concept. So let's try another one. Number 2, show that 5 is the upper bound and -3 is the lower bound. Well, I didn't ask you to graph it, so I don't need to graph it. So I'm going to use a synthetic division. I'm going to check 5, and then I'll do it again and check -3. So we got here 1, -2, -9, 2, and 8. So bring down, we got 1, 5, 3, 15, 6, 30, 32, 160, and 168. All positive. That's what I'm looking for. So all positive. Therefore, this is the upper bound. Try it again. Bring down. So we got -3, -5, +15, 6, -18, -16 makes +48. And we add that when we get 56. The signs go positive, negative, positive. They're alternating. That makes -3 the lower bound. Well, that was it. So thanks for watching. Have a nice night.